Have you ever wondered why data scientists spend so much time preparing data before the actual magic of machine learning begins? The truth is, the quality of data pre-processing can make or break a machine learning model. Today, we dive into the world of label encoding and one-hot encoding, two pivotal techniques in the pre-processing toolkit. Imagine you have a dataset of cars including a column for car colors, red, blue, and green. Machine learning models, however, inherently prefer numbers. They can't quite handle red or blue without a little translation. This is where label encoding comes into play. Label encoding converts each value in a column to a number. For instance, red becomes 0, blue becomes 1, and green becomes 2. It's a straightforward approach. Each unique category gets a unique integer. Consider this Python code to perform label encoding using the popular library. Now, while label encoding is incredibly efficient, it introduces a new problem: numerical relationships. The model might interpret the numerical values as having some sort of order or magnitude relation, which they don't. For example, it might think green, which we encoded as 2, is somehow twice something of red, encoded as 0. This is where one-hot encoding saves the day. One-hot encoding creates new columns for each category and assigns a 1 or 0. Red, blue, and green each get their own column, and for each car, only one of these columns will have a 1 at a time, indicating the presence of that color. Here's how you can implement one-hot encoding in Python. This snippet will produce a data frame where the color column is replaced by 3 columns, one for each color, filled with zeros and ones, depending on the car's color. Output. In conclusion, label encoding and one-hot encoding serve as fundamental steps in the pre-processing phase of building machine learning models. Label encoding is simpler and very efficient, but it should be used with caution when the categorical variable doesn't have an inherent order. On the other hand, one-hot encoding, although it may increase the dataset size, avoids unintended ordinal assumptions and is generally safer for nominal categorical data. Understanding and applying these techniques correctly ensures that the input data is well prepared, paving the way for building robust and effective machine learning models. Remember, in the realm of data science, every detail in pre-processing counts just as much as the final analysis.